NNM Neural Network Analysis, an Individual, and Longitudinal Big Data, AI Study of Aging. Number 1261, VMT Sharp 644, April 28, 2025. Gerald C Hsu, eclaireMD Foundation. Category, Longevity. Abstract. This study applies a neural network big data AI model, NNM, to analyze aging patterns, based on three key influential factors over a shorter longitudinal span, from 2014 to 2025, offering a micro-viewed perspective. This work complements the author's earlier macro-viewed study, using the viscoplastic energy model, VMT, across 5 factors over a longer period, from 2011 to 2025, presented in his paper number 1259. The reason for selecting the from 2014 to 2025 time window is that data from 2010 to 2013 were incomplete, which significantly affects NNM model accuracy, whereas the VMT model is less sensitive to such gaps due to its use of annual average data. Additionally, this NNM study narrows its focus to 3 influential factors: visceral fat percentage, VF%, fasting plasma glucose, FPG, and food portion size to simplify his data interpretation workload. Using 16,476 data points, 4 variables across 4,119 days, the author employed NNM to detect outliers, data points that deviate from predicted healthy behavior bands and thus warrant special attention. Unlike the VMT model rooted in physics, material science and engineering, the NNM model derives from computer science and emphasizes data pattern recognition at a microlevel, like observing through a microscope, while the VMT model provides energy-based contribution ratios to highlight which long-term factors dominate disease progression. The NNM model reveals precisely when, and in which factor, behavioral or physiological violations occurred. These outliers represent signals of accelerated aging or disruption, akin to identifying cancer cells in early imaging diagnostics. Through targeted health interventions focused on these 3 factors, the author successfully reversed his biological aging, from being approximately 2.1 years older than his real age in 2014, health age 69 versus real age 67, to approximately minus 12.6 years younger in 2025, health age 65 versus real age 78. In effect, he gained 15 biological years of life. Methodology: the output variable was defined as health age difference, health age minus real age, used as the x-axis in all spatial diagrams. The 3 selected stress inputs, y-axis, were: input 1, visceral fat percentage, VF%, input 2, fasting plasma glucose, FPG, normalized to 120 mg per deciliter, input 3, food portion size, grams per meal. NNM steps. 1. 2D spatial mapping. For each of the 3 inputs, a 2D spatial diagram was constructed with aging difference on the x-axis and individual input values on the y-axis. Each diagram contains 4,119 blue plus points representing a data cloud. 2. Pattern recognition and boundary bands. A green centerline representing the data cloud's orientation, regression slope, was calculated to reflect data correlation. 2 predictive boundary boxes were then established, plus minus 10%, red, and plus minus 20%, yellow. These represent acceptable behavioral zones in AI pattern recognition terms. 3. Outlier detection. Data points outside the yellow boundary were flagged as violators or outliers, similar to cancerous cells on a CT scan. A subroutine recorded the date, X value, and Y value of each outlier. 4. Outlier percentage calculation. The number of outliers for each input was divided by the total data points, 4,119, to calculate the violation percentage. NNM results. The NNM analysis yielded the following outlier counts and percentages. Visceral fat, VF%, 29 outliers, 0.70%. Fasting glucose, FPG, 11 outliers, 0.27%. Food portion size, 14 outliers, 0.34%. Shrinking the boundary bands would naturally raise the number of outliers, but this analysis used a consistent plus-minus 20% threshold for all inputs. Importantly, the relative ranking of outlier percentages reveals the dominant rule violators in aging. 1. Visceral fat, most frequent outlier. 2. Food portion. 3. FPG, least frequent outlier. These results closely match the author's personal health history. He struggled for many years with his visceral fat percentages, which only fell below 13% in 2023. In contrast, his FPG levels dropped below 100 mg per deciliter by 2021, after effective T2D management beginning in 2011. His initial FPG at 200 mg per deciliter in early 2011. Meanwhile, his food portion was cut from 1,088 grams per meal. Normalized at 1.60, in 2011 to 680 grams, normalized at 1.0 by 2014, and further down to 286 grams, normalized at 0.42 by 2025. These lifestyle improvements correspond closely with the observed NNM outlier patterns. Conclusion: traditional statistical methods are incapable of capturing the macro-level disease patterns revealed by the VMT energy model. Global view, or the micro-level outliers identified by the NNM Big Data AI approach. Local view. As a professionally trained mathematician and engineer with a long-standing career in high-tech product development and scientific research, the author deliberately avoids relying on statistical tools, fully aware of their limitations in addressing the complex, nonlinear, and dynamic nature of chronic diseases and multifactorial challenges such as cancer and aging. By applying both methods to his personalized longitudinal data, the author identified three dominant drivers of accelerated aging: visceral fat accumulation, insulin resistance via FPG, and excessive food intake. Among them, his visceral fat is the most problematic, NNM outlier, 0.70%, VMT energy, 34%, followed by his food portion intake. NNM, 0.34%, VMT, 29%, and his FPG level, NNM, 0.27%, VMT, 37%. Metaphorically, the VMT model is like a medical internist who sees the whole organ system of patient, while the NNM model functions like a medical surgeon who pinpoints the specific areas requiring intervention. Through systematic lifestyle optimization over the past 11 to 15 years, the author reduced his health age difference from plus 13.72 years in 2011 and plus 2.1 years in 2014 to minus 12.59 years by 2025. This age reversal process confirms the power of targeted metabolic control, and validates both the VMT and NNM models as superior alternatives to traditional statistical tools in longevity or other challenging medical research. Although based on a single subject case study, the findings present universal principles for slowing aging. Individuals who maintain visceral fat below 13%, early morning FPG below 80 mg per deciliter, daily average glucose below 120 mg per deciliter, food portion around 680 grams per meal or less, walk over 7,500 steps per day, and sleep 8 hours per night, can expect marked improvements in both health span and lifespan, without needing further statistical validation from large cohort studies. Moreover, in recent years, the author has compared his personal longitudinal results with national population level data across various diseases and influencing factors. Despite minor numerical differences, the patterns and trends between the individual and population data were strikingly consistent, further strengthening the generalizability of these discoveries.